Hello and welcome back. This is going to be a big one. uh, we'll start by covering arrays within MATLAB, actually declaring vectors and matrices within MATLAB, and then we'll get into the different manipulations that you can do with said vectors and matrices. Now, to start off, arrays within MATLAB. The main three arrays that we want to focus on are scalar, vector, and matrix. Now, a scalar is any single value, so we've already done this, declaring x as equal to 1 or 2, any integer value, anything that is a singular value is scalar. So a vector is a one-dimensional array consisting of two or more elements. It can either be a row or a column. And matrix is a two-dimensional array consisting of at least two rows and at least two columns. Uh, this should be pretty familiar to everyone. Just wanted to cover it, but now that we know what vectors and matrices are, we can actually get into how to, actually input them within MATLAB. So let's start with vectors. So a manual input of a vector within MATLAB. So what you want to do is use two square brackets and assign the variable a name. And essentially what you would say is like we've said is a vector, but you can say x, y, whatever you want, is equal to brackets, close brackets, and inside you can put in all the different elements that you would want within the vector. So in our case, we have 1, 2, 3, 4, 5, and you would separate each element using a space, a singular space. Now, this vector right here consists of 5 elements because we've put in 5 elements. So it's like assuming that you output this within the command window or even within the workspace, it should only show 5 elements within the vector. Now, the second method of creating a vector is using the line space function. So what the line space function basically does is you have a variable name, obviously, and then you have the function itself. What it does is that the first element, or x, is going to be the first element within the array. Y over here is going to be the last element within the array, and n is going to be the total number of elements within the array. So for example, let's say we declare a vector using line space and we say that the first element is going to be not 20, 0. The last element is going to be 20, and then within the whole vector itself, we're only going to have 5 elements in total. So it would start counting from 0 to 20 and only have 5 elements, so 0, 5, 10, 15, 20, etc., etc. Now, another way would be log space. So log space is similar to line space, but different at the same time in that uh, x would be to the power of 10. So x would be the starting power of 10 element within the array, y would be the ending power of 10 element within the array, and n would still be the total number of elements within, the vector. So for example, let's say 0. So 10 to the 0, 1. So the first element within the vector would be 1. 10 to the 1, 10. 10 last element within the vector would be 10. And then we have 10 elements within the vector in total. So it would start counting up. So let's say 10 to the 0, then 10 to the point 1, etc., 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 all the way up to 10 to the 1. And then it will output this specific elements based off of the power of 10. Now, I can show this within a MATLAB instance really quick as well. If I can open this. Yep, there we go. Let me clear the workspace. I still haven't cleared it from the previous video. What I can do is... Oh, this is add element. We need vectors. There it is. Okay, there. Vector manual. Okay, run. So I didn't want to output this within the command window, but we can still see it within the workspace. So we've created the manual vector. So the manual should only have 5 elements. It does. Line space we've created, and it has 5 elements, just like the example, and same goes with log space. So essentially, you can create a vector using these 3 different methods. Now, what we can do is actually get into same thing, but with matrices. It's the same snippet. So we're probably going to be sharing these slides, so you wouldn't have to watch the videos, just go through the slides. But matrices within MATLAB. So, manual way of entering a matrix. So, what you would essentially do is set up a variable, and same thing, open bracket, close bracket. And since we know that matrices are at least 2 rows and at least 2 columns, we would have to separate out the rows and the columns. So, what we would do is that each row is going to be separated by spaces, and each column is going to be separated by the semicolons. Wait, am I getting that correct? No, that can't be correct. Each column is separated by the space. Why did I put row here? Each column is separated by the spaces, and each row is separated by the semicolon. So, for instance, we'll have 1, 2, 3 at the top, 4, 5, 6 right underneath, and 7, 8, 9 right underneath that. I should probably fix that, but essentially that's what it is, and that's how you would create a manual matrix. I'll show this within MATLAB as well. But another way to create a matrix is using zeros. So what it would do is create a matrix, but all the elements within the matrix would be as zeros. But all you would have to do is type in the number of rows and the number of columns within the matrix. So x would be the number of rows, y would be the number of columns, and every element within the matrix would be a 0. And the next would be the same, but instead of zeros, it's all ones. So again, number of rows, number of columns, everything is going to be a 1. Now, the last way to actually declare matrices is the I function. This creates an identity matrix. Identity matrix basically, it'll be better explained when I actually show you how it works, but what it does is it creates a diagonal element from top left to the bottom right, which is going to be equal to 1, and all other elements within the matrix are going to be equal to 0. It'll be better explained when I actually show you, but what you would do is type in matrix I, and the y is going to be equal to the number of rows and columns. Since this is identity matrix, both would be equal. So let's launch up MATLAB and matrices. This should have everything. Yep. Clear workspace, and then we can clear the command window as well. Run this. It's over here, but it's better explained over here since these are matrices. So again, the columns separated by spaces, so we have 1 column, 2 column, 3 column, etc., etc. Rows separated by the semicolon, so 1 row, 2 row, 3 row, and we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, just how we predicted within the manual entry. Now within the zeros, we have 3 by 3 matrix, and everything's going to be a 0. Same thing with the 1, but except everything's going to be a 1. Now with the I function, uh, identity matrix, you guys should know what this is, but it's going to be a 3 by 3 matrix with the identity matrix. So we'll have top left to bottom right, all ones, as you can see right here, and everything else is a 0. So these are the basic ways to input a matrix within MATLAB. Let me present again. But this should cover the basic matrix or vector entries that you can do within MATLAB. And what we can actually do now is actually get into the different operations that you can do within or with vectors and matrices as well. So to start off, we'll start with the transpose operation. So what transpose basically does is it, like, I don't want to say if, yeah, it basically flips a vector or a matrix. So let's say you have a vector that's only one, is one dimensional obviously, but it's, as you can see, it's a row. And what you can do is turn it into a column by using the transpose function, or you can just do inverse. So I'll actually show you guys how to actually do this within MATLAB, but same thing with the matrix. So the row becomes a column, and the, you know, column becomes a row, etc., etc., etc. Now let's find this transpose test. and again clear workspace, and then CLC, and then run this. Okay, so we have our vector with 4 elements in it, 1, 2, 3, 4, and to inverse it, what you can do is just get the vector that you've already created, and you can just label it vector inverse, and you would just type in a single quote, and this should transpose the vector. Same thing with the matrix as well. No matter how big the matrix is, you can do a transpose function on the matrix as well to just basically do an inverse of the matrix. That about covers the transpose function within MATLAB. So, addressing individual elements within arrays, specifically vectors and matrices. So, to start off with vectors, what you would want to do is essentially you would have a vector v, and you would say v of whatever position you want to change. So, let's say in our instance is 3, and whatever element is in that position, so in the position of x, you would change that to whatever integer that you would want to change it to. So for instance, in our case we said 7, so what so vector at 3 is going to be equal to 7, so you would go 1, 2, 3, third position, element is 3, we're going to change that to 7, as you can see right here. Now, if you have taken CSCI 111 and you know about C++ or any other programming language, you'll know that the positions within vectors are treated differently within those respective languages, because in C++, for instance, if you have a vector and you want to refer to the first position, you wouldn't say uh, array at 1, that would give you 2. You would say array at 0, that would refer to 1. But in the case of MATLAB, each individual position is respective to their element. Well, at least in our case, so 1 would be 1, 2 would be 2, etc., etc. It starts from 1 and it keeps on going within the vector. That's important to know. So next we'll show you how to address individual elements within matrices. So we know that matrices are two-dimensional, so we would have to have an x and a y value to refer to the position within the matrix. So if you know the size of your matrix, let's say 3 by 3, right? In our case, it is 3 by 3. And let's say you want to refer to the middle, just the exact middle element. So what you would do is x is equal to 2, y is equal to 2. So you would go to the row, so x is equal to 2, so y is equal to 2, so the element is 5, but we want to change that to 0. So as you can see, we changed it to 0. So let's say we did 1 and 3, so x is equal to 1 and 3, so 1 and 3, this would be changed to 0. As you can see, pretty simple individual elements. Next is actually addressing groups of elements. So with groups of elements, at least in regards to vectors, what you would do is you have a starting position and an ending position, and these two will be separated by the semicolon right here. So x would be the starting, y would be the ending. So let's say in our instance we have starting from the third position going all the way up to the 7th position. You want to change all the elements between those to 0. So we see that 3 to 7 is changed from, or 3, all the elements within 3 to 7 are changed to 0. In matrices rather, is a tad bit more different because they are, two-dimensional. So there's actually multiple ways to change elements within matrices. Uh, all You can pause the video here if you want to just review these, but I'll actually show you guys a quick example, or like a visual example, to help you guys better understand how the changes actually occur within the matrix within MATLAB. So I'll open up the instance. Okay, workspace is clean, command window is clean, and we are on the correct uh, MATLAB code. Okay, I'll run this and we'll go all the way up. We only have one variable because we're only working with one matrix, so we declared a matrix 3 by 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what the first one does is, what it says is every element within the third column. So every element within the third column, change that to 0. So you go to the third column, every element is changed to 0, just as this says. The second part, what it says is every element within the third row, change that to a 1. So every element within third row is 1, as you can see. Now you can actually manipulate this even more in case of the second one. So let's say you want to change 2 whole columns. So you would say every element, and it's separated by the comma right here, every element within column 2 all the way to 3. So in case, let's say we had 7 different columns, right, it would be 2 all the way to 7, but in our case it's a 3 by 3, so we only have 3 columns, so 2 to 3. We're gonna change all of these to 2. So as you can see down here, both columns 2 and 3, all the elements are changed to 2. Now, same thing but with the rows over here. So what this says is every element within rows 1 and 2, change that to a 3. So every element within row 1 and 2 are changed to 3. Now, the last one over here is very specific. You can change individual, or not individual, a collective group of elements wherever within the matrix. So let's say within rows 1 and 2 and within columns 2 and 3, change that to a 4. So rows 1 and 2, but it also has to be between columns 2 and 3. So these top right 4 would be changed to a 4. You see how this manipulation occurs, or how you actually change elements within the matrix as opposed to just a vector. It's a bit more complicated, but not that hard to comprehend. So now that we know how to address groups of elements within arrays, specifically vectors and matrices, what we can go on to do is actually add elements to vectors and matrices. So if you want to add an element, so let's say our vector is only has 4 elements, right? For vectors only. Let's say the vector only has 4 elements and you want to add more elements to the vector. So what you would say is from 5 to 7, notice that within this vector 5 to 7 doesn't exist. So you would be adding 3 new elements. So you would say 5 to 7, let's add 5, 6, 7, and then it would add that to the original vector. Now, similar thing applies to the matrix as well. So let's say we created a 2 by 3 matrix, right? So we only have 1, 2, 3, 4, 5, 6. But we want to add a third row to the matrix. So what you would do is third row, and all third row, this indicates the elements within the row, and you would add 7, 8, 9. So you would add 1, 2, 3, 4, 5, 6, and then the new 7, 8, 9 to the original matrix. So this is how you would add elements to a pre-existing vector or a matrix. Now you can also delete elements from arrays and or in our case vectors and matrices, just by declaring whatever you want to delete as a null. So open bracket, close bracket, and then that's it. So the same thing applies when you're referencing the positions. We've already covered how to, reference the positions. But in our case, what we were going to do is just delete them. So we're just going to set it equal to null. And as you can see with this 5 to 7, 5 to 7, we set that to null. No longer there. Over here, the third row, we're setting the whole third row to null. Third row disappears. It's pretty simple. Deleting elements from an array. Now, there are different functions for matrices as well. So, for instance, the size function, what this will do is it will actually get the total number of rows within the matrix and assigns them to x, and the total number of columns, and it assigns them to y. So it actually returns essentially the size of the matrix. And the length of the matrix, what this does is it returns the number of elements in the largest dimension from the matrix and assigns it to z. So over here, let's say in the largest dimension, so 4, right? So it's a 4 by 3, so the length would be 4. So it returns a 4 to the matrix over here, so z would be equal to 4. Since we have some time left within this video, we might as well just go through the basic arithmetic in regards to arrays as well, and then Randall can cover the basic time to frequency transformations and some examples in regards to filter design. But as of right now, let's go through some basic arithmetic that we can do with arrays. You can also do these with integers as well, but we're going to cover arrays. So when it comes to addition and subtraction, you got to make sure that the arrays must be the same size. So let's say if you have array or a vector, let's just say a vector full of four elements, and you want to add it to another vector, you have to make sure that the other vector is also full of four elements, and each element will be added in accordance to the position that it is in within the vector. So let's say we have a vector of two elements, and both elements in position 1 will get added. Both elements in position 2 will get added, and then an answer will be given back in the form of a vector that also has two elements, but with the elements being added. And to actually do the addition with MATLAB, you have to do dot plus or dot minus. I'm pretty sure you don't have to include dot for the addition and subtraction, but for the multiplication and division you do. So for multiplication, there are a set of rules that you have to follow. So, for instance, when it comes to multiplication, let's say matrix 1 is M1 and matrix 2 is M2, you have to make sure that the number of columns within matrix 1 matches the number of rows in matrix 2. And the same rules apply for division as well. From multiplication, you do dot the multiplication sign, and for division, same rules apply, but we have two different forms of division. We have left division and right division. In case of left division, so for example, let's say we have A left division B, it's basically equivalent to B divided by A. And for right division, A right division B is basically equivalent to A divided by B. Now we can also do exponential of matrices as well with dot the exponential symbol right here. And I'll actually open up MATLAB to show you guys the different arithmetic that we can actually do. So let me clear workspace, clear. I'll just do CLC. Okay, so let's run this. So we have a 2 by 2 matrix, or yeah, we have two 2 by 2 matrices. So M1 is 1 2 4 5, M2 is 3 2 6 5. And when it comes to addition, so let's say 3 1 and 2 2, 4 4 up top, 6 4 and 5 5, 10 10 at the bottom. As you can see, it multiplies in accordance to the position. And oh, not multiply, adds. Same thing with the subtraction. It subtracts each element according to its position within the matrices, and same goes with the multiplication. So let's say 3 times 1, 3, 2 times 2, 4. We have 6 times 4, 24, 5 times 5, 25, etc., etc. And then we also have exponential as well, which the answer is given right here. And then division right and division left. The orientation does matter because it basically states which matrix is being divided by which matrix. So it's really important to know that it's really important to know what left division and right division essentially mean. And with this, I'm pretty sure I covered the basics of arithmetic when it comes to arrays. This will be useful later on when Randall's talking about filter design. Arrays, or rather matrices, do come into play when you're working with filter design because you have transformation functions, etc., etc., etc. But as of right now, I'm pretty sure I have covered the basics. Randall will take over with the fast Fourier transform, and hopefully you guys can learn a lot from Randall. He's a very smart guy. And for now, I will say goodbye. I might be back later to do another example for filter design, but we're also planning on doing a workshop for Simulink as well. Simulink is one of the products that we got for MATLAB. It is very useful in the fact that you can actually simulate circuits. If you're not going to be using LT-SPICE, you can actually simulate circuits within MATLAB as well. We'll do a Simulink workshop later on. It might be separate, or it actually might just be incorporated within these videos. But as of right now, you guys should be pretty comfortable with the basics of MATLAB, and Randall will take it from here. So, see you guys soon, and goodbye.